Now to finalize, because we're over the hour now, upcoming innovations. What's coming up? What we see that's coming up. So two big things are coming up. I think in this chart where we have the public domain and the commercial satellites, we'll have more and more use of the nanosatellites and the aerial photographs and the UAVs especially. The nanosatellites will have a 3-band RGB and the near infrared, so it will be useful for the NDVI calculations. We're still checking if it's going to be used for other indexes. We believe it won't be. It will be good for imagery or for NDVI. But the good thing is it will have very high resolution, 3.7 meter, and daily, every other day revisits. It will have a high order area with lower costs. So this is an opportunity to talk with ag service organizations and provide this as a larger scale with a lower cost per farmer. But we need a lot of farmers in order to make this very, very affordable. The good thing is more like a Netflix model. The idea is to provide a subscription area, and every image that goes through that area can be downloaded. So I think this will be an industry changer breakthrough. And again, the UAVs are also a good promise. We need to make it more operational, but it's also great technology. And just to give you an idea of what this means, we do not endorse Planet Labs. It's one of the companies. There are 3 companies that we know that are working with nanosatellites, 2 in the US, 1 in Argentina. This is the one that's coming up from, well, US, Canada, Germany, really, because they bought Rapida, which is from Germany originally, and Blackbridge is a Canadian company. I'm not sure if it's US or Canadian, but their pitch is imaging the whole Earth every day. How they achieve this, it's amazing technology. Technology evolves rapidly, becomes smaller, and this is no exception. This is a representation of the size and the complexity of the NASA Landsat 8 satellite that we're currently using. And the Planet Labs, or the nanosatellites, they call it DOVE, very poetically. Satellite, it's very small. It's 30 centimeters and maybe 50 centimeters in width for the solar panel. So it's like a shoebox, basically. And what they have achieved, they are producing this at large scale, and they're sending this in tens, in group of tens, and so we expect to have hundreds, 150, 200 of these nanosatellites constellation, which allows them to revisit every spot in the Earth every day in the future. So this is what it looks like. This were the satellites that they launched on January 9th, 2014. That's where we're getting the trial images from. Now, maybe the life of this device is 1 year, but it's so cheap to produce, so easy to use, that they will keep launching this to keep the constellation running. So these were 28 doves, between quotes, so they call it a flock of doves, that was launched in January, and they continue launching these satellites. So this is their plan for this years, 2015 and 2016, depending on the latitude. I think South Africa, Argentina, Brazil, it's more in the minus 30 degrees latitude. So the revisit time between 10 and 20 days now. Now it's going down to 5 and 10, depending on the launches that they are releasing, going down to 3-7, and by the end it should be every day visit. So we're testing in a couple of farms in Brazil, Argentina, South Africa, and Paraguay, just to see how this performs, and we'll keep you posted. If you don't mind getting a letter from us every month, we'll keep you posted on how this evolves. So this is very promising. We're very excited. I think this will change, like the cell phone has changed the way we operate. I think this will change the way that we monitor crops. UAVs, it's very promising. It's now a reality. Now there are challenges. Operational, logistics, having the right guy, the right time there. It's limited to a couple of hours in the morning because otherwise you get shadows. You need trained personnel. the UAV will go down at some point. Sorry to tell you this, our partners from Geoagro Africa, but chances are that they bought a UAV, and the statistic is that after 1 year, after 2 years, after 2 months, for some reason, something will fail. It will go down. So it needs to be this experience we're getting from UAVs service providers from different countries. It needs to be very affordable so you can replace it, and you have to calculate for short amortization periods. Processing complexity and time is a big issue. You can take the image the same day, but if it takes 1 month to process, then no gain. So what we expect in the near future is cheaper, faster, more reliable. There's a question there about service providers or do-it-yourself. So we expect companies using that service model that they will distribute the UAV very cheap and any farmer can buy it, but then they have to operate it, they have to process the information. So along will come a data processing infrastructure. We know one company in South Africa, one company in the US is setting it up, one company in Argentina is setting it up. It's a little bit behind. One company in Brazil that we met last week, it's providing the service with these challenges. So we see the same issues everywhere. It's not large scale yet, but we expect that it might be, and there might be a niche there, a segment for UAVs, a segment for nanosatellites in the future.